Hello everybody, today we're going to solve rational equations. Let's talk about the different ways you can see these equations and kind of the different steps you might take to solve them. So, one thing you can do when you're solving rational equations is you can cross multiply. Now, so if there is a proportion, if you have a proportion, you can cross multiply. So let me show you what that looks like, multiply. So example 1, let's say I have 3 over x plus 1 equals 9 over 4x plus 5. So proportion is when you have a fraction that equals another fraction. There's nothing added to the fraction, there's nothing separated from, like subtracted from the fraction, it's just one fraction equals one fraction, okay? Then you can cross multiply. So when you cross multiply, right, I'm going to multiply this way and then this way. So I have 9 times x plus 1 equals 3 times 4x plus 5. The key when you're cross multiplying is to go ahead and make sure that all of your binomials are always in parentheses. Always put binomials in parentheses, okay? So that being said, from here, very simple, you would go ahead and distribute. So I have 9x plus 9 equals 12x plus 15. Then I'm going to just solve, this is a linear equation with x's on both sides. So I'm going to put all of the x's together, so 12 minus 9, 3. So I have 3x plus 15. I'm going to subtract 15 from both sides. So that would be 6. Divide both sides by 3 and x is equal to negative 2. Now, of course, you can always check that. So when you go back to check, you're just going to take your equation. Everywhere there's an x, I'm going to put in a negative 2 because I think that is going to keep both sides of this equation equal. So that would be 3 over negative 2 plus 1 equals 9 over 4 times negative 2 plus, times negative 2, there we go, plus 5. I want to make sure I'm only multiplying by negative 2 there. Then this gives me 3 over negative 3, which is equal to negative 1. I have 9 over negative 8 plus 5, right? And that gives me 9 over negative 3, right? Yeah. That's not negative 3. 9 divided by negative 3 is negative 3. That's not negative 3. Oh my goodness, you guys, check it. Y'all, hey everybody, negative 2 plus 1 is negative 1. Just gonna, I don't know what I was thinking. That's negative 1. 1 divided by negative 3 is negative 3. There we go. Both sides are equal, so this does check. Okay, then. Now, sometimes you can't cross multiply, so let's talk about what happens in that case. If you can't cross multiply, then the thing you want to do is you just want to, or you can just go through and you can eliminate your denominator. And let me show you how to do that. Now let's start with something really simple and then we'll kind of get more complex because eliminating denominators can get a little bit messy. So example 2, let's say we have 5 over x plus 7 over 4 is equal to negative 9 over x. Now what I'm going to do to get rid of these denominators is I'm going to multiply both sides by the same number. Now I can multiply both sides by anything I want as long as it's the same number. So, and I'm going to multiply both sides and make sure that everyone has all of the denominators. So in my denominator, I have x and I have 4. So what I'm going to do is multiply this side by 4x. And I'm going to multiply this side right here by 4x. Now, when I do that, you're going to see some interesting things. So 4x, now don't forget to distribute, okay? So 4x times 5 over x is 20. 4x times 7 over 4 is 7x. And negative 9 over x times 4x is negative 36. That eliminates all of my denominators, and I can then solve just a regular equation with just a single variable equation, single variable linear equation. So 7x would be equal to negative 56. Divide both sides by 7. And let's see here, 56 divided by 7, I want to say it's 8. Yeah, 8. Okay. And then, of course, you could easily check that. We're just going to go back and substitute in that negative 8. So I have 5 over negative 8 plus 7 over 4 equals negative 9 over negative 8. That's positive 9 over 8 right there. And then, of course, I need a common denominator here. So I have 5 over negative 8 plus 7 over 4 times negative 2 over negative 2. So that would be 5 over negative 8 plus negative 14 over negative 8. And that would give me negative 9 over negative 8, which is 9 over 8. And so that one checks as well. Now, sometimes our fractions can be a little bit more complicated than that, or it's not even a fraction at all. So let's look at something else. Okay, so another situation that you might see here is you'll have like a whole number in there. So let's say I have 1 minus 8 over x minus 5, and I have that is equal to 3 over x. Now in this case, a lot of times my students will think this is a proportion and will go ahead and cross multiply. Don't do that. This is not a proportion. There's a whole number minus a fraction equals a fraction, not a proportion. This can be really confusing to students because of that whole number. I'm still going to follow the exact same steps though, and I'm going to do it in a way to get rid of the fraction, okay? So I want to get rid of the denominators, so I need to multiply both sides by both denominators. One denominator is x minus 5, the other denominator is x. So this side of the equation, I'm going to multiply by x times x minus 5. I'm going to multiply the entire left side of the equation by this. And then I'm going to multiply the entire second side of this equation by x times x minus 5. Okay? So both sides are multiplied by the same thing. Okay? Now, by doing that, don't forget to distribute. Okay? So if I distribute, I end up with x times x minus 5, because that times 1 would just be itself, minus the x minus 5's will cancel in this case, so I have 8x here, equals the x's will cancel out in this case, and I have 3 times x minus 5. Yeah, that's a minus sign right there. Okay? From there, I'm going to distribute to get rid of parentheses and then solve the equation. So I have x squared minus 5x minus 8x equals 3x minus 15. Now, by doing this, I have noticed that I've given myself a quadratic equation because I have x to the power of 2. So since this is quadratic, I'm going to go ahead and set it equal to 0 and then factor or use quadratic formula. We'll see which one we have to do. So I need this whole guy to equal 0, so I'm going to subtract 3x and add 15. So that gives me x squared minus 8x, add these are both x. What? More steps. Let's see, let's just make this a little bit more clear. Let me put these two x's together. Negative 5x and negative 8x together. I have negative 13x, and I want to subtract 3x, and I want to add 15, and all that equals 0. So that's x squared minus 16x plus 15 equals 0. Now that is factorable. Okay, cool, because I need, let's see, I need two numbers that multiply to give me 15, add or subtract to give me negative 16. I can do negative 15, negative 1. So let's do x squared minus 15x minus x plus 15 equals 0. Factor out the GCF for the grouping. These first two, factor out the GCF, factor out the GCF for the second group. And I have x minus 1 times x minus 15 equals 0. Zero product property tells me that one of these factors has to be equal to 0. At least one of them does. So they could both equal 0, which means x is 1. That's a possibility. Or x is 15. Now I am going to need to check this. I need to make sure that they both work. They could both work. That is absolutely a possibility. They could also both be duds. So let's find out. So they could be extraneous or they could be legitimate. So let's find out. So I'm going to check the number 1 first. So 1 minus 8 over 1 minus 5 equals 3 over 1. I just took the original. I substituted a 1 back in there. So let's see. That's going to give me 1 plus 2. 1 plus 2 surely is 3. So that one worked. Let's check 15. Now 3 over 15 is the same thing as 1 over 5. Okay, so and then I have 1 minus 8 over 10. 8 over 10 is 4 over 5. And then I could think of 1. I'm going to rewrite the number 1 as 5 over 5. That way I can subtract it really quickly. So I'm going to use the number 1. I'm going to write that as 5 over 5. And then that gives me 1 over 5. Hey, it works. This one works too. Fantastic. All right. Now there's one more thing I do want to bring up. So let's look at one more example, and then that'll kind of be what you're dealing with in this particular set of problems. Okay. So example 4. I believe we're on number 4. Let's do 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. Okay, let's talk about this. So again, I'm going to do the same thing and try to get rid of that denominator. It's not a proportion. I have a fraction equals a fraction minus a fraction. So to be a proportion, I have to have one fraction equals one fraction. That is not what I have. So I would really rather get rid of the denominator. Now, I need to multiply by every single thing that happens to be in a denominator. This guy, I'm going to go ahead and factor this first. That way I can see exactly what is in that denominator, okay? So by doing that, I'll keep this first guy the same. This is a difference of squares. So I'm going to go ahead and factor that out to x minus 3 times x plus 3. And then leave the rest the same. Now by doing that, it's really easy for me to see what I need to multiply, what I need to multiply both sides by. So I need to multiply both sides by an x minus 3 and an x plus 3 because clearly x minus 3, x plus 3, and both of them are in denominators, right? And I'll do the same thing to this side. I'll multiply it by x minus 3 times x plus 3. Okay. Now when I do that, on this side here, the minus 3's will cancel. And so I have 6, I'm going to kind of skip a line just for clarity, 6 times x plus 3 on the left. And remember, I'm distributing, okay? So these numerators and these cancel out, so I have just 8x squared for that first term, minus the x plus 3's cancel out, so I have 4x times x minus 3, okay? Go ahead and distribute and solve. So that gives me 6x plus 18 equals 8x squared minus 4x squared plus 12x. I'm going to go ahead and combine like terms real quick. So that gives me 4x squared plus 12x. Notice that you have x squared. That means this is a quadratic, so I need to set it equal to 0 before I finish solving. So let's see. set it equal to 0, so 0 equals 4x squared. I'm going to subtract 6, so I only have plus 6x, and then I'll subtract 18. And from there, I would factor. Now, in this particular case, I'm going to go ahead and factor out a GCF. I like to have small numbers. So if I factor out, they both, 2 would go into all of these numbers. So if I factor out a 2, I'm left with 2x squared plus 3x minus 9. And I'd like to see if that's something I can factor. Let's see. So I need two numbers that multiply to give me negative 18 and add to give me 3. Ooh, let's see. 9 and 2, no, 6 and 3. Yeah, what if I do positive 6, negative 3? That would work. Okay, cool. So I have 2 times 2x squared plus 6x minus 3x minus 9, right? Took these two terms, I put them here. Then I will do my factor by grouping. That gives me x plus 3 in the parentheses. So my factors are going to be 2x minus 3, and x plus 3. That means that either 2x minus 3 is equal to 0 or x plus 3 is equal to 0. So x would have to be 3 over 2, or x happens to be negative 3. Now, I want to make sure that I check these because it's likely that one of them works, both of them work, or none of them work. They could be extraneous. Extraneous meaning a solution that was correctly, like you solved correctly, but that solution doesn't work. So let's look at our options here. So I'm going to check 3 over 2 first. So I have 6 over 3 over 2 minus 3 equals 8 times 3 over 2 squared over 3 over 2 squared minus 9 minus 4 times 3 over 2 over 3 over 2 plus 3. Okay, let's see here. So 6, okay, so 6 over 3 over 2 minus 3 would be, okay, so 3 is, so times 2 is 6. So 6 over 2, which gives me 6 over negative 3 over 2, which is times negative 2 over 3, which is negative 12 over 3, negative 4. Okay, let's simplify the other side. Right. So 8 times 9 over 4 is 2 is 18. Right? And that would be 9 over 4 minus 36 over 4. Minus 6. Right? That would be 6, right? So that'd be 12 over 2 is 6. Yep. Okay. Now I have some common denominators. It'll be a little bit easier. So I have 18 over negative, what is 36 minus 9? 27? 6 over 9 over 2. Okay, let's rewrite these. So I have 18 times negative 4 over 27 minus 6 times 2 over 9. That gives me 3 goes into that 6 times, goes into that 9 times. Ooh, could have made that smaller. 3 goes into that 2 times, goes into that 3 times. Okay, negative 8 over 3 minus, oh, you can't see what I'm doing. All right, goes into that 3 times, no, 2 times, goes into that 3 times. So minus 4 over 3. Oh, fantastic, I'm really loving this. Equals, negative goes into negative 12 over 3, which is, negative 4, baby. Yes, it checks. Score. This one's a good one. Yes. All right, let's just check this other one. I'm going to switch colors because I'm going to try to shove it in the corner. So I'm going to switch colors just so you can see what I'm doing over here in this corner. So I'm going to take -3 and I'm going to put that in my original problem. So I have 8 times -3 squared over -3 squared minus 9. I can already see this is going to be a problem. Let me show you why. Right here. This is where I saw it's going to happen right here too. -3 squared minus 9, that's 9 minus 9. 9 minus 9 is 0. Here I have -3 plus 3, which is also 0. That puts a 0 in my denominator. I cannot divide by 0, therefore this is not going to work. I can already tell you, because that would be undefined. So I only have one answer. It's that guy. Very good. -3, he would be extraneous. And there you are. That's how you do it. Have fun.